Hey squad, I thought it might be helpful if we went through a quick review of Chapter 5 on integrals. Remember that integrals are referring to things that are accumulating, accumulator functions. There's a couple different skills that you might need to do with your integrals. The first one is approximate the integral. This is what we did all the way back in the very beginning of Chapter 5. There were two shapes that we used to approximate. The first was Riemann sums. Anybody remember what that was code for, I hope? Rectangles. Okay, so if it says Riemann sums, you're thinking about rectangles. You might have a left rectangle, or a right rectangle, or a middle rectangle. What was the other shape we used? That's right, we used trapezoids. So anytime it says trapezoidal approximation, you're going to draw trapezoids. Remember the area of a trapezoid, 1/2 height, base plus base. Now it's not required, but you're going to see these questions a lot when you see table questions. I would strongly encourage you to draw the picture first and then add the shapes together. That's going to lead to greater success than if you try to just play with the numbers as you go. So draw the shapes, add them up, you got an approximation. The next skill we did was evaluate. This was our definite integral. A definite integral has a definite answer. There are three main ways that we can evaluate. The first one, if it's a calculator question, you should probably use your calculator. So you can go ahead and type it into math, go ahead fint, and use your calculator. Again, if you do not like your operating system, you can download Calculate 84 as an app on your phone. Make sure you put it on your phone, not your iPad, because when you're taking the AP test, your iPad will be locked. Our middle method was to just add up what I called signed areas. So if the triangle was above the x-axis, it was positive. If it was located downstairs, it was negative. Add them all up. Last but not least, we used our antiderivatives. We said this is really the same thing as an antiderivative from a to b, and then we plugged in f of b minus f of a. For our antiderivative method, you need to know your antiderivatives. So go back and check your memorizer elsers. We can post that again to Schoology. Make sure you know what you're supposed to memorize. Okay, our next skill is finding the derivative of an integral. This was everybody's fan favorite, fundamental theorem of calculus. Fundamental, do you think that's going to be on the AP test? I think yes, definitely. So if my original function's an integral, then the derivative of an antiderivative, you guessed it, gets you back to the original fu, not inappropriately, times the derivative of the upper limit. Remember, for this game to work, the lower limit was a constant. The upper limit might be some formula, which is why we have the chain rule and we multiply by its derivative. We're going to do quite a few AP practice questions this week with fundamental theorem of calculus. Okay, two more topics to go. If we see average value of a function, we're kind of thinking about average junior high style, but now we want to do it in a high school way. So our high school way of adding everything up is to take the integral, my accumulator function, and then I need to divide by the total number that I have, whatever my interval is. Okay, last but not least, we talked a lot about rates questions. Again, this is most likely going to show up on our AP test. This is when we are given an input and an output rate, and we want to think about the total amount. So I had a quick little formula we talked about where the total is going to be the initial amount plus the accumulation of my input rate. Remember our bananas question, whatever's getting added on, minus the accumulation of our output rate. And you want to be careful with the times. When did it start? Were they happening over the entire interval? If I want to find a max or min of the amount, we are going to think about our derivative. Okay, the derivative, well, the derivative of a value is just 0. The derivative of an antiderivative would get me back to the input rate minus the output rate. So often for these questions, they're going to ask you, when did a max or min occur? If I take my derivative and set it equal to 0, my critical value will happen exactly when the input equals the output, when my two rates are the same. So keep that in mind, check your units. I hope to see you soon.